Assalamualaikum warahmatullahi wabarakatuh. My name is FATIHAH binti HASBULLAH, and today, together with my group, I will present a fascinating study titled A Feasibility Study on Exhale Breath Analysis Using UV Spectroscopy to Detect COVID-19. This study addresses a critical issue, the need for a rapid, accurate, and non-invasive diagnostic method for COVID-19. To begin, let's briefly talk about COVID-19. What is COVID-19? COVID-19 is a disease caused by SARS-CoV-2 which has led to a global pandemic claiming nearly 7 million lives. While most individuals experience mild to moderate symptoms and recover, others, especially older adults and those with this highlights the importance of timely and effective diagnosis. Currently, diagnostic methods often rely on complex and expensive techniques such as gas chromatography, mass spectrometry, or GCMS. These methods, while accurate, increase testing costs and limit accessibility. To address these challenges, the study explores exhale breath analysis as a promising diagnostic tool. Specifically, it focused on the potential of UV spectroscopy for detecting volatile organic compounds or VOCs for exhale breath. These VOCs, particularly carbonyl metabolites, are linked to oxidative stress and inflammation that are associated with viral infections like COVID-19. Now, let's look at the objective of the study. Firstly, the primary goal is to evaluate whether UV spectroscopy can distinguish between healthy individuals and symptomatic COVID-19 patients by analyzing the UV absorbance of their breath samples. Second, the study also aims to assess the efficiency of silicon microreactor technology, which selectively concentrates carbonyl VOCs in exhale breath. This technology prepares the samples for precise and efficient UV spectroscopy analysis. Last but not least, the study seeks to establish UV spectroscopy as a cost-effective and quiet alternative to existing diagnostic techniques, eliminating the need for expensive and time-consuming methods like GCMS. This approach offers the potential for a single, rapid measurement using a less expensive instrument, making it both practical and accessible.
For the next part, I will talk about method procedure for the feasibility study on exhale breath analysis using UV spectroscopy to detect COVID-19. The process begins with sample collection, where exhale breath samples from 23 subjects, which is 13 COVID-19 positive and 10 healthy individuals, are collected in 1 liter Tedlar bags. These samples are then evacuated through silicon microreactors, which contains functionalized micropillars specifically designed for pre-concentrating carbonyl volatile organic compounds. This ensures the sample are properly prepared for the next stage of the analysis. Next, in the microreactor coating stage, the micropillars are coated with a reagent called 2-amino-oxy and N-trimethylene, 1-ammonium salt. This coating allows the micropillars to form non-volatile oxide, ether adducts with carbonyl VOCs, thereby capturing them effectively. An internal reference IR is included in this step for normalization purpose during subsequent analysis. The captured carbonyl adducts are then subjected to elution using 200 microliters of methanol. This process extracts the adducts from the micropillars, making them ready for further analysis. Methanol serves as an efficient solvent to isolate VOCs from accurate detection. Next, the UV spectroscopy steps involves measuring UV absorbance using a Beckman culture DU800 spectrophotometer. The absorbance spectrum is scanned across a wavelength range of 200 to 550 nanometer. Methanol solution containing the ATM carbonyl adducts are analyzed using a 100 microliter quartz cuvette, ensuring precise measurements. Data is then normalized based on the internal references absorbance at 458 nanometer to account for variability. Finally, a feasibility study is conducted by comparing the normalized UV spectra of the samples. This comparison focuses on detecting differences in absorbance patterns between healthy and COVID-19 positive subjects, particularly within the 235 until 305 nanometer range. These critical steps determines whether the UV spectroscopy method can reliably distinguish between the two groups, establishing its potential for COVID-19 detection. Which is result and discussion. Our study used UV spectroscopy to analyze exhale, breath, and differentiate between healthy individuals and COVID-19 positive subjects. We observed statistically significant differences in UV absorbance, particularly in the 235 to 305 nanometers wavelength range. COVID-19 positive samples showed higher absorbance value, indicating elevated level of carbonyl VOCs in their breath. At 236 nanometer, the mean absorbance for COVID-19 positive subject was significantly higher at 59.4 plus minus 21.1 compared to 37.3 plus minus 9.4 for healthy individuals where P less than 0.04. This suggests UV spectroscopy could be a potential tool for detecting COVID-19 through exhale, breath, and feces.
Next, we proceed to the role of carbonyl volatile organic compounds. First, it elevated UV absorbance in COVID-19 positive sample correspond to higher concentration of specific carbonyl compounds like aldehydes. These compounds are produced during lipid peroxidation and indicate oxidative stress and inflammation, both associated with viral infection like COVID-19. Examples include metabolites like heptanal and nonanal, which contribute to the UV absorbance pattern seen in COVID-19 biomarkers. For selection of an indicator region, a compound called 3,2-benzoyl 7-diethylamino-coumarin was chosen as an indicator region for normalizing UV absorbance in volatile organic compounds detection. It has a specific absorption peak at 458 nm, which does not interfere with detecting carbonyl volatile organic compounds. This region ensures accurate detection and quantification of aldehyde biomarkers in breath sample. It demonstrates excellent reliability with a high linearity, which R squared equal to 0.9986 when plotted against concentration.
Hi, my name is Hazirah binti ABDUL Halim, and today I will present about importance of analyzing the analyte. Analyzing analytes such as carbonyl volatile organic compounds in exhale breath is crucial because they serve as biomarkers that provide insight into underlying physiological and pathological conditions. In the case of COVID-19 detection, the study highlights that viral infection induces oxidative stress and inflammation, which correlate with increased level of exhaled carbonyl compound. By isolating and analyzing these biomarkers, a rapid and non-invasive diagnostic method can be developed. This is crucial for managing public health emergencies, enabling early detection and reducing the spread of highly contagious disease like COVID-19. In this case, we choose UV spectroscopy because minimal water interference, sensitivity to biomarkers, and rapid and simplified workflow. Minimal water interference. Unlike infrared spectroscopy, UV spectroscopy experiences less interference from water vapor in breath, making it more suitable for direct breath analysis. Next, sensitivity to biomarkers. The method effectively detects alpha beta unsaturated carbonyl compound due to their high molar sensitivity, ensuring sensitivity even at trace level. Lastly, rapid and simplified workflow. The integration of silicon microreactor technology for chemoselective pre-concentration allow for a streamlined process that concentrate analytes for accurate UV absorbance measurement. In conclusion, UV spectroscopy combined with silicon microreactor technology offer a fast, affordable, and non-invasive method to detect COVID-19 through exhale breath. By analyzing carbonyl volatile organic compound, it revealed clearly differences in UV absorbance between UV positive individual and healthy people. This method has potentially to replace more complex and costly techniques. However, factors like age, smoking, and other health conditions must be considered to improve accuracy. Large studies with diverse groups, including asymptomatic individuals, are needed to confirm its effectiveness and clinical value. This research prove this research provides a solid basis of UV spectroscopy to detect disease linked to carbonyl volatile organic compound changes such as COVID-19.